Hopefully a fun and exciting video here at Blue Glow Electronics today. This is an interesting one. So, your typical, I've got dozens of these things, just USB thumb drives. They come in all shapes and forms. This is a Kingston little thing slides in and out. You got these little kind that spin around like this. But this one, it was actually like this, one of the ones that kind of slides out. And it didn't survive so well. So what happened was someone had this plugged into their laptop, and then when they dropped their laptop, this thing ended up being inside the laptop, and this wasn't. It kind of just bent the whole thing back and broke it off, and all 4 pins here came loose in that process. And so I've kind of taken the thing apart at this point, and sure enough, it's completely separated from this little board here. But we're going to see if we can actually repair this thing and get it functional, because the person that owns this has a lot of very important data on this little chip right here, and they can't get to it. And they would be very, very upset if they can't get this data back off of here. So we're going to see what we can do to remedy that situation. Okay, we're using a trusty magnifying glass here to help amplify this thing a little bit, but you can see here that on this little board here, there's 1, 2, 3 little 4 places right here, and unfortunately those 4 places have been completely ripped off. So if I slide this out of the way, you can kind of see here that the pins along with the traces that were stuck down on the board are completely gone. So it's not as simple as soldering 4 little wires right here back, because there's nothing to solder to at this point. All that got ripped off. So what we're going to end up having to do is find the traces connecting to those, like right here, and use a X-Acto knife and kind of come along here and scrape off very carefully just enough trace for us to be able to solder to. Okay, if you've watched any of my videos, you know I use the Heiko FX888D, which is a great sub $100 soldering iron. I would highly recommend it to anyone. But as you can see, the size of this tip is pretty darn big compared to what we're going to be soldering here. So what I'm going to have to do is replace it with a really ultra fine little tip here that'll help me do the soldering I need. So we'll just screw this thing loose and get our tip swapped out. Okay, up next I'm going to use some 2x28, or in other words 28 gauge wire. It just happens to be a twisted pair, and I'm going to untwist these, but the 28 gauge wire should be sufficient for what we're going to use here. This is silver Teflon coated PTFE coated wire, but you could use any fine 28 or smaller gauge wire. Okay, as you can see, I've cut 4 equal length pieces of wire about 2 inches long each, and we're going to strip the ends of both of those. And since this is Teflon coated wire, I'm having to use a wire cutter, a wire stripper that gets hot on the ends here and strips the ends off a thermal stripper. Alright, we've got both ends of our wire stripped, and what we're going to do is go ahead and attach 4 ends of those onto this. I had thought about breaking open an old unit here, like one of these, and soldering it into it, but I actually think I straightened out the bent ends on this thing. I actually think the connector is still good. We're just going to have to tag in from a solder standpoint to all 4 of these connections right here. Okay, I would recommend kind of coming along and using a little solder and tinning the ends of each of these little wires with a little bit of solder, just a little bitty dot on each end there, so that when you go to put it onto the little connector here, it'll be easy to attach. And if you'll notice, I went ahead and went into each one of these little trays here, got it good and hot, and then kind of fed it in with some solder. So if you'll notice, all 4 of those are kind of flowed and full of solder at this point in time. Alright, and as you can see then, I just used and kind of held a piece over into the tray or right on top of it, and used a soldering iron to kind of heat it up and drop it down in there. And as you can see now, that's soldered good and well within that tray. So I got a nice extension piece now. Alright, I can show you here. I'm doing one. I've got it kind of laid on top. Get some solder flowing a little bit. Get it going down in there good. And all of a sudden you've got a nice wire connected in there and good to go. Alright, we've got 4 connections now. All these made nice and well. I'd be able to plug this right into a computer now. We've just got to get these other ends connected to this actual chipboard here. So if we actually turn this end, if you notice the original solder leads were down this way, and they would have actually been on top of this chip just like this. And if you'll notice, this this outer shield would have actually been soldered onto, so I may end up with a 5th wire going to the ground here. But I'm going to get these 4 grounded. I'm going to get these 4 soldered down into these spots first. Like I mentioned, we're going to use a little X-Acto knife to get down in here using the magnifying glass and clean out a little bit around right beside of or into the trace that they were attached to, so we can solder to something. Alright, so if you kind of take a look at the pin out, the way it would be laid here, with this thing coming out just like this, it would be, and I'll show you. It would be the very right one would be USB VCC, so plus 5 minus 5 volts. Then USB data minus USB data plus. Your data actually flows over these 2 middle ones. Then you've got USB ground. So this 4th one here is ground, and it's the same ground as the outer shell that this thing is connected to. So now I've kind of laid this little board in the same orientation, and let me zoom in here now and let you see what I've done, if we can get it here. So there we go. What I've done now, and it's a little hard to see here, but I have gone in and I have started scraping off the traces on this little board at this point. And I've got enough copper here on this point over here. And if you remember, the very left one, that one was ground. Then the 2 data ones, and it's kind of hard to tell, but on one data one, and you have to get this thing at an angle to actually be able to see the copper trace. But I've cleaned off the copper trace over here. And for the middle one, I've cleaned off the copper trace right here. In other words, I didn't clean them off side by side, because then it would be easy for the solder to flow between the 2 of them and or the wires to touch. So I'm going to connect one of them here, and I'm going to connect one of them up here. And then this one here, this last one, is actually a feed through. If you flip the thing upside down and notice on this side, it actually has right there whatever's coming off of this side of this little component. It's a resistor. It feeds through the board here into the other side, so I've got to tag onto that little piece. You know, so it shouldn't be too bad. I've got the copper kind of broken away. You can see it right there, 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 and there. So we're going to get to soldering. Probably not going to solder this with the camera on, but you get the idea. Okay, it's a little tough to see here, but kind of turn it a little bit. You can see I've got all 4 spots soldered up. Had to bend the wires a little bit to get the lengths, because they weren't all, even though the wire lengths were the same, the lengths on this board were not the same. So we're going to take it over and plug it in and see if it works. If not, we'll have to come back and do some touch up on the solder. And as you can see, we've inserted the drive here. Drive K popped up. You can see it's full of files here, and we are going to start copying these things off to a safe location and get these back to the individual. You know, there could be a couple other scenarios where a drive fails. You know, I guess one, it got some kind of moisture in there and actually caused some damage to the circuit itself, fried some component or something. That'd be a little tougher to solve. If the chip itself was broken too, that's going to be about impossible to solve. But you know, if the board was broke, there's a chance you could rework all the traces and get that going again. So thanks for watching, everybody. Stay tuned. We'll keep bringing them to you.